Good morning, students. Chapter 4, Moving Charges and Magnetism. Yes, in last lecture we have discussed velocity selector, cross field. When electric field and magnetic field, they are perpendicular to each other, then what happens? Okay, yes, due to both of them forces acting on charge. Another use of cross field means electric field and magnetic field when they are perpendicular to each other. Cyclotron. Now, what is cyclotron? Okay, what is its use, principle, construction and working, we will see in this chapter. Okay, use of cyclotron. Cyclotron is used to accelerate charged particles to high energy. Okay, what is use of cyclotron? It is used to accelerate charged particles up to very high energy. Okay, so yes, it is its use. These highly charged particles are then projected on a nucleus for their disintegration to study some fine structure of matter. Yes, again, these charged particles which are accelerated up to high energy, they are used. So what is use of cyclotron? Use of cyclotron is to accelerate charged particles up to very high energy. Then these highly energetic particles are bombarded, are incident, are projected on nucleus or objects which we want to study its fine structure. Clear about this? So yes, it is its use. What is principle? See here. We know that when charged particle enters magnetic field normal to it, when charge enters magnetic field normal to it. We know that when charge enters magnetic field normal to it. For example, magnetic field perpendicular to God going inside magnetic field. Yes or no? Charge particle Q enters with velocity v in this direction. Then yes, we know that it will perform circular motion. So yes, we know when charge enters magnetic field normal to it, charge performs circular motion. For that circular motion required centripetal force is provided by magnetic force due to magnetic field. It is provided by magnetic force. Centripetal force. If radius of this circle is r, mass of charged particle is m, then what is centripetal force? Yes, we know centripetal force is mv square upon r is equal to, what is magnetic force? Magnetic force is qvb sine 90. Yes or no? Yes, it is. Sine 90 is 1. This weaker. Yes or no? Yes. Then we can write r is equal to, it is mv upon qb. Or I can write r is equal to, it is p upon qb. Yes, we know this equation. Yes or no? Yes. Okay, so see, from this we can say this r radius depends on p, means linear momentum. Yes or no? Yes, this r depends on linear momentum. So if linear momentum increases, its radius increases. Okay, r depends on p. Radius of circle depends on linear momentum. Linear momentum, its equation in terms of kinetic energy. If you know, then yes, it is under root 2 km upon q. Yes or no? Yes. Kinetic energy is equal to, it is half mv square. So yes, it is m square v square. It is m square v square upon 2m. Then it is p square upon 2m. Then yes, p is equal to under root 2 km. P is equal to, it is under root 2 km. So yes, we can say that this radius of circle depends on linear momentum and also on kinetic energy and also on its energy. Clear about this? So yes, this first point that you have to remember. Now, in this equation, see, in this equation, m, I can replace this v as omega r divided by r is equal to, it is q. Yes, you know, v linear speed, omega angular speed, and it is r. Then see, this r by r. Then omega is equal to, it is qb. Omega is equal to, it is qb upon m. Omega is equal to, it is qb upon m. Clear about this? Omega means angular frequency. To see angular frequency, charge of particle always remains constant. M, mass always remains constant. B, magnetic field is uniform. Means we can say that this angular frequency is not dependent on linear momentum or energy. This omega is not dependent on linear momentum or energy. Okay. Or if I simplify this omega, then yes, I can write omega is equal to 2 pi f. It is 2 pi f is equal to qb upon m. Then how to write f? Yes, f is equal to, it is qb upon 2 pi m. Then see, you observe this equation of omega and f. They are independent of linear momentum and energy. They are independent of linear momentum and energy. Means, what is conclusion? Omega and f, they are independent of linear momentum and energy. So what is conclusion of this theory? Conclusion of this theory is, if momentum or energy of charged particle changes, radius of circular path changes, but angular frequency or frequency remains the same. Clear about this? Okay, if P, or I can say yes, linear momentum or energy changes, radius of circular path changes, but frequency of revolution, it remains constant. And it is principle of cyclotron. Clear about this? Okay, if increased linear momentum or energy of charges, radius of circular path of charge changes, but frequency of revolution remains constant. Okay, it is principle of cyclotron. Now, what is construction and working? See here construction. Magnetic and electric fields are used. Cross magnetic and electric field. Okay, see, two magnets are placed like this. Two magnets means magnetic poles, like it is north, it is south. North and south. Clear about this? Yes, okay. Like it is north and it is south. So uniform magnetic field is in this direction. Yes, it is uniform magnetic field. It is uniform magnetic field. Clear about this? Yes or no? Yes, it is uniform magnetic field. Okay. In this magnetic field, two hollow disk conductors are placed having size and shape of letter D. Okay, like this, like this. Okay, D-shaped conductors. D-shaped conductors, hollow conductors, hollow conductors. Okay, two D-shaped hollow conductors. They are placed like this, face to face. Okay, one like this, another like this. Okay, yes, gap between them is very small, but here to make figure clear and clean, yes, we have two D's, D1 and D2. They are placed like this. They are placed near to each other like this. Okay, it is one D, it is another D, and two magnets are like this. It is North Pole and it is South Pole. Yes or no? So magnetic field is in vertical direction, and these D's are perpendicular to it. Clear about this? These D's are perpendicular to it. Clear about this? And yes, they are hollow. They are hollow. They are hollow. So charge can easily move inside them. So charge can easily move inside them. Clear about this? Clear about this? Now, what happens? See. You say, sir, there is electric field only. Where is magnetic field? What about this magnetic field? What about electric field? Yes. These two D's are connected with AC source, oscillator, with AC source, AC source, or yes, you can say oscillator. What is function of oscillator? Why it is called AC source? Why it is called AC source? See, yes, in chapter number 7 we will study in detail what is AC and what is DC. AC current means which changes its direction. If I draw graph, it is graph of AC. It is graph of AC like this. Okay, continue. See, during this time, whatever value of voltage is positive, during this it is negative. Now, when voltage becomes positive and negative, when their polarity is changed. When their polarity is changed. Okay, AC source means what? See, you know this type of connection. It is resistance. This hand is always positive, this hand is always negative. It is DC source. It is DC source. Yes or no? Yes, it is DC source, direct current, DC source. Means this value, this terminal of battery always remains positive and this becomes always negative. Yes or no? Yes, it is. But if I have AC source like this, AC source like this, then during first half cycle, if this end is positive, it is negative. During half cycle, it will become negative, it will positive. During the next half, it will become positive, it will become negative. So yes, it is meaning of AC source or oscillator. Okay, polarity of this source changes. During first half cycle, if this end is positive, this end is negative, then during next half cycle, polarity is reversed. Polarity is reversed. Clear about this? So it is difference between AC and DC. Yes, right now you have to remember this difference. DC source, battery, cell, this terminal always remains positive, this terminal negative. Yes or no? Yes. But in AC, polarity plus minus changes. During first half cycle, if it is positive, it is negative. Then during next half cycle, its polarity is changed. Again, its polarity is changed. Clear about this? Clear about this? So now, see, this oscillator is connected between D1 and D2. Is connected between D1 and D2. Clear about this? Okay. So yes, oscillator. Let at some time, for example, during this first half cycle, this oscillator is connected with these two D's such that potential of this D1 is positive and potential of this D2 is negative. Clear about this? Oscillator means two terminals, one has positive potential, another has negative potential. At this point is positive, it is connected with this D means it will be at positive potential. It is connected with D2 means it is at negative potential. Clear about this? So yes, we have here positive potential, here negative potential. So due to positive and negative potential, there is some potential difference and there is some electric field. Yes, there is electric field. And see, this electric field is in this region only between two Ds, from positive terminal to negative terminal. From positive terminal to negative terminal. So yes, it is electric field. Clear? See. 2Ds, it is D1, it is D2, then electric field is in this direction. Clear about this? Clear about this? So yes, electric field is in this direction, magnetic field is in this direction, cross fields. Clear? And yes, this whole arrangement is evacuated, placed in vacuum chamber. Why to vacuum chamber? Because here we have to accelerate charge particle. So whenever charge particle enters in air, it will collide with air particles, and yes, there is loss of energy. So when it is placed in vacuum chamber, okay, it will not collide with any charge particle. Means it will perform its circular motion to high kinetic energy. Clear about this? So yes, it is its construction. Again, North and South Pole. North and South Pole. Magnetic field from north to south. Okay, in vertical direction. 2Ds are placed like this. Yes or no? It is D1, it is D2. There is space between them. With these 2Ds, oscillator, AC source is connected. Okay, so yes, let at some time, initial time, this D is at positive potential, this D is at negative potential. So there is electric field between two regions. Now you may answer, there is no electric field inside this D's are conductors, they are hollow. Remember chapter 2, electrostatic potential and capacitance. Remember topic, electrostatics of conductors. Remember first point, inside conductor electric field is zero. Inside cavity electric field is zero. So yes, in this region electric field is zero. In this region electric field is zero. Electric field is only between two D's. Between two D's in this region, in this region. Clear about this? Clear about this? But inside this D's there is magnetic field. Yes, these two D's are placed like this. There is magnetic field perpendicular to it. Clear about this? So yes, it is construction of cyclotron. Now we will understand what is its working. Now we will understand what is its working. See, what is working? Here it is. At initial time, let at time t is equal to or initial condition. Okay, initial condition. This D1 is at positive potential. Yes or no? Yes. D2, it is at negative potential. Yes. So electric field is from positive plate towards negative plate. Yes, you know it. Yes, you know it. Yes or no? Yes, it is. Now, in this region, we have electric field. If I place at this point one charge, positive charge, remember positive charge, then yes, we know that positive charge is attracted towards negative charge, negative plate. So yes, if in this region at this point, if you drop or if you place positive charge, that positive charge is attracted towards this negative plate due to electric field. Due to electric field, it is accelerated. It is accelerated means its speed increases. Its speed increases, its linear momentum increases, its energy increases. This concept you have to remember. Okay, due to electric field, charge particle is accelerated. Due to acceleration, its speed increases, its linear momentum increases, its energy increases. Clear about this? Yes. So see, this charge particle is moving towards this plate in this direction. Okay, see, in this direction. magnetic field is perpendicular to it. So this charged particle enters this d2. Yes or no? This charged particle enters in this d. Now in this d, electric field 0. What is present? Only magnetic field. And yes, see, this charged particle enters magnetic field normally. It enters magnetic field normally. So yes, it will perform circular motion. So yes, this charge will perform circular motion. It will perform circular motion. Clear about this? Now the most important thing. The most important thing. Okay. AC source, it has frequency. Frequency means it changes its direction. It changes its direction. See, positive, negative, positive, or this one. It changes its polarity, plus, minus, plus, minus, plus, minus. So, what is frequency? What is frequency? If it changes its direction, here it is. When charged particle enters in this field, it is moving, moving, moving. This frequency of oscillator is selected such that when this charged particle is on the verge to exit this D, is about to exit this D, this D1 will become now, negative potential and D2 will be at positive potential. Yes, I can set this frequency. I can set this frequency LC oscillator. How to set? Okay, when this charge is about to exit from this D, I have decided frequency such that now this D comes at negative potential and it is at positive potential. Then now electric field is in this direction. Then as this charge is moving in this region, again due to electric field from positive D to negative D, it is again accelerated. Accelerated means its speed increases. Its speed increases means its linear momentum increases. Its energy increases. And see this statement, energy increases, radius of circular path increases. Yes, directly proportional. See, R is equal to P upon QD. So as linear momentum increases, why linear momentum increases? Because its speed increases. So its radius increases. Again, due to electric field, it is accelerated, its energy increases, linear momentum increases, so radius increases. In this D, there is no electric field, only magnetic field, so it will perform circular motion. Clear about this? Now again, it is moving on circular path, Again, when it is about to escape, when it is about to exit from this D, polarity, frequency of this AC source is such adjusted that now it will become negative and it will become positive. So yes, again direction of electric field is changed. So this particle is again accelerated, linear momentum increases, energy increases and its radius also increases. Clear about this? Okay, on circular path, again its energy increases, radius of circular path increases. So it is how, see, in this region between two plates, due to electric field, it is accelerated, its energy increases. So in these, its radius of circular path increases. Yes, radius increases, energy increases, radius increases, energy increases. Okay, at some point, for example, whenever it enters or whenever it is at this point and it is about to escape, due to another strong magnetic field, this charge is then, with the help of here one cap, it is targeted on particle. It is targeted on some object. It is targeted on some object. So what happens here? Initially charged particle is here. Due to electric field, energy increases, radius increases. Energy increases, radius increases. Energy increases, radius increases. Its energy, as radius increases, energy increases, energy increases. And highly kinetic energy particle, it is then projected on the nucleus. which we want to disintegrate. How to deflect this? Due to another high magnetic field. Clear about this? Or due to another source. So it is working of cyclotron. But what is condition to operate this cyclotron? Yes, polarity of these things. If in the case whenever this charge is about to exit from this D, and if this plate is not at negatively charged, then will it accelerate? No, it will be not accelerating. Then what is condition? See what is condition. It is frequency of cyclotron, this charge moving. Frequency of cyclotron, Fc, this charge moving. Okay, then Fc, frequency of cyclotron, must be equal to frequency of oscillator, Fa, frequency of oscillator. It is conditioned to operate this cyclotron. If frequency of revolution of this charge is equal to frequency of this AC oscillator, then and then this cyclotron will work. Otherwise, yes, you can understand that if this charge is about to exit and if it does not become negative, then will it move towards it? No. Will it be accelerated? No. Will it gain energy? No. Then how to increase its radius? How to increase its energy? Cyclotron fail. Clear? So yes, it is one important condition to operate this cyclotron. Frequency of cyclotron means frequency of revolution of charged particle is equal to frequency of AC oscillator. Clear about this? So yes, use, principle, construction and working. Clear about this? In working, yes, in working you can write in your own language. It is totally given in textbook with the help of 2 paragraphs how this cyclotron works. So yes, that working of cyclotron you have to write from textbook. Clear about this? Right. See, we have 2 very simple questions based on this. Example 4.3. Yes, electron is moving. Mass of electron is 9 into 10 raised to minus 31 kg. Charge of electron 1.6 into 10 raised to minus 19 volt is moving on circular path with speed V is equal to 3 into 10 raised to 7 meter per second. In magnetic field, B is equal to 6 into 10 raised to minus 4 Tesla. Then your first question is, what is equation of radius, or what is radius of circular path of electron? What is radius of circular path of electron? Yes, you are given one condition, students, that this electron enters magnetic field normal to it. So yes, we know that when charge enters magnetic field normal to it performs circular motion. And yes, for circular motion, you know what is equation of radius? Yes, equation of radius R is equal to mv upon qv. M given, V given, Q and D, each and every point the value is given. Yes, you can easily find. What is frequency? Yes, you know what is equation of frequency. And if you don't know, then yes, you have to put value. See, R M V is equal to omega R upon QB, R cut. Okay, so omega is equal to, it is QB upon M, or F is equal to, it is QB upon 2 pi M. You can easily find Q, it is given, B is given 2 pi, you know, and M is also given. So yes, you can easily find what is its frequency. Last question is energy. What is energy? Yes, you know equation of energy. E is equal to half mv square. What is unit of mass? Kg. What is unit of mass? What is unit of V? Yes, it is meter per second. So if with this data, mass 9 into 10 raised to minus 31 kg, V 3 into 10 raised to 7 meter per second, and if you calculate energy, your answer will come in Joule. Yes, your answer will be in Joule. Your answer will be in joule. To convert this joule in electrovolt, yes, you have to divide your answer by 1.6 into 10 raised to minus 19 electron. Clear about this? So yes, remember this point, you have to multiply this. Okay, next question is example 4.4. Oscillator frequency of cyclotron is 10 megahertz. What is oscillator frequency? Is Fa. Then what should be value of magnetic field such that charges are accelerated in these having radius 60 centimeter. What is value of V? What is value of V? See how to find. Yes, we know what is for cyclotron, to operate cyclotron. Fa is equal to Fc. So yes, it is equation of frequency if you remember. So I can write Fa is equal to Qb upon 2 pi m. Yes, it is electron. Okay, so yes, you know what is charge. You have to find magnetic field. You are given Fa 2 pi m. You know each and every data. If you are given electron, then yes, you know data of electron. If you are given proton, then yes, you are also given data of proton. You know what is value of proton and electron. Okay. Another question is, yes, from this you have to be a subject. Then B is equal to, it is 2 pi m Fa upon. Another question is find kinetic energy. What is equation of kinetic energy? Kinetic energy. K is equal to, yes, it is half mv square. Kinetic energy K is equal to, yes, it is half mv square. Okay. How to find kinetic energy? See, yes, you can use this relation. R is equal to is mv upon qb. You have value of m for electron and proton, but you do not have value of V. Then how to find V? See, we can find V with the help of this equation also. V means linear speed. Speed means distance upon time during one rotation. What is value of circumference? It is 2 pi r. And what is time? It is t. Or simply, if you want to make it subject from this, you can also make. Okay, if V is equal to it is QBR upon M. Clear? So yes, put here value. K is equal to it is half M. V square means Q square, B square, R square upon M square. M cut. You have value of Q, you have value of B, you have value of R. Divided by 2. Put each and every value, you will get your answer. Clear about this? Okay. So yes, these two questions are easy based on cyclotron and motion of particles, charged particles in magnetic field. Okay.